Okay, so it's going to start the video right here. Missed that first part. Okay, so this time for the translation vertically, again, if we look behind the shade, all that stuff is kind of hard to understand. So I just want to show you with an example. So let's go up to this time. All right, so g of x or y equals 3x minus 5. And this is the y. So I'm doing it to the y basically, which is the y is like the g of x. So this whole thing is the y. So I'm going to do what when I go up to? Add or subtract to? Add. When it's vertical, we go how we think it should go. Up is addition, down is subtraction. And we just add it on the end, on the vertical one. And then we clean it up, we simplify. And just combine the like terms, which is 3x minus 3. Okay, so this time let's see if it went up to. So go back to my y equals, so I'll keep the first one the same. This time, we're going to make it minus 3. All right, so let's see if it goes up from the first one. I hit graph. There's the first one. There's the second one. Go up to. Yeah, it went up a little higher, right? They look the same. They're parallel. Okay. We just moved it up 2 units. So those aren't too bad. The translation stuff is pretty easy. Any questions?
So basically you're just going down 5 and then up 2.
Well, the original was when we've stretched it by 3 and went down by 5, right? But we started out with this, F. Okay, so basically all we did is added 2 to make it move up 2. If I wanted to go down 2, I'd subtract 2 and make that a negative 7 then. Okay, when it's horizontal, then I'm messing with the x. So we went right 2, remember we think it's the opposite. Right 2 and subtract 2. And left 2 would have been adding 2. Anything else? Those are the easier ones. It gets a little tougher, but I know you guys can handle it. Okay, let's look at a couple examples here quick. All right, so here's our function, 2x plus 1. 3 units down. So is that vertical or horizontal? Vertical. So all I got to do is what when it's 3 units down? Subtract 3. So I just go g of x equals 2x plus 1 minus 3. That's all you got to do. And then combine like terms. What's 1 minus 3? Negative 2, right? So vertical's the easiest of all. Left and right, we got to think a little bit more. We start out with the same function, 2x plus 1. This time they use tell us to use h. So we got the 2, and now we're taking care of the x part. And the plus 1 is still there. 2 units left. We just did that, didn't we? Or did we do 2 units right? We already did 2 units right, didn't we? So 2 units left, what do we do? X plus 2, right? And then to clean it up, we'll distribute our 2. 2x plus 4 plus 1 is 2x plus 5. That's our new function that moved 2 units to the left. Okay? Translation. Simple. You can do it, no problem. Right, Ben? Good. Emma? Okay. Good. All right. Reflections. This stuff behind the shade, you can kind of understand better. All right, the graph of y equals negative f of x is a reflection in the x-axis of the graph of y equals f of x. The black one is the y equals f of x. The red one is y equals negative f of x. Multiplying the outputs. The outputs are what you get. The outputs of the y, or the f of x, I guess. Changes their signs. Okay? So, we're still given f of x equals 3x minus 5. Okay? And remember, that's the same as y equals 3x minus 5. Just want to remind you that. Okay? So that's what my y equals. My y is my output. All right? So when I do a reflection in the x, I am taking the opposite of the whole thing. Okay? My y will end up changing. And I distribute my negative sign. And that's our finished reflection. The y changes when you reflect about the x. You're taking the opposite of the y, the output. Okay, so if I look at this, got my 3x minus 5, now negative 3x plus 5. So my negative sign's down here at the bottom under the 3. Negative 3x minus 5. Oh, sorry, plus 5. Graph the first one, just like before. And there's the other one, reflection about the x. Okay? The y changes when you do reflecting about the x. Right above graph, it says table in blue. If I hit my blue button here, second graph, it gives me the table of values for both those graphs. Okay, as you can see, the first y was negative 11, the second y is positive 11 when you put negative 2 in for x. The y changed. That's what happens when you reflect about the x. Right, Zane? Okay. So just a quick visual there on the tables. You can look at that on your calculator if you want to. Okay, reflecting about the y-axis. All right. We take the opposite of the x. The x changes. Okay, multiply the input. The inputs are the x values, the domain. The output is the y values, the range. Okay. All right. So again, we're starting with our same f function. And we're going to reflect about the y this time. Okay, so g of x equals 3 times negative x minus 5. We're changing our x. Just that part, not the whole thing. All right. So basically all it does is that negative x, we can make that negative sign out front of the 3. That's our reflection about the x-axis. The x changes. So if we have a little graph here, X, Y table here, let's get rid of these dots. Okay, and I have a point here, let's say that's 2, 2. That point. Reflecting about the y-axis would be this way. If it's 2 to the right, 2 to the left, that's a little off, sorry. But that would be negative 2, 2. If I'm just 2 each way. So the x changed, right? When I reflected about the y-axis. Okay? Okay. Example. We got an absolute value one this time. Write a function of g whose graph is a reflection in the x-axis of the graph. Okay? So g of x equals the whole thing. Get those a little longer. Put the negative out front of the whole thing. Now, that negative out front of the whole thing makes my absolute value negative and my 1 negative, right? So there's our answer. You cannot distribute the negative into the absolute value. Okay? You just leave that negative sign out front. Don't take that in there. Remember, we're changing the y. So that's why again, we could have wrote y equals this, right? So changing that y is, I guess y equals up there. Changing this y is changing that whole thing, because that's what y equals. Taking the negative of it, multiplying it by negative 1, I guess. Okay? Reflection in the y-axis. So this time it's h. Okay, the same, we start with the same one. All right? Absolute value, and then negative x plus 3 plus 1. Put it inside, right? You're just doing it to the x. And that I can't really simplify. I can drop the parentheses, I guess. But I can't really do anything to that. So that's our reflection about the y. Okay. And that's when we changed the x. So we changed it from positive x to negative x. Okay. Absolute value. Let me go over that one. Let's put that one in the calculator just so I can go over that with you again, because that's been a couple days. All right. So the original was absolute value of x plus 3 plus 1, right? So got your y equals. We're here. Absolute value is math, and then move right 1 with your arrow key to number, and ABS stands for absolute value. So hit enter, and then you can write x plus 3. Mine, you got to use a parenthesis. Some of you have newer models. It'll look like straight lines like normal. Plus 1. So there's the original, and reflecting about the x, we put the negative. Math, move it over, absolute value of x plus 3 again, close it up, but it's -1. So let's look at those graphs. There's the first one, and there's the other one. If I fold along the X, that goes right on top of that one, right? Okay. Questions? All right. Next one. Vertical stretches. We're not going to worry about horizontal stretches and strengths. This gets kids really confused. So we're just going to concentrate on vertical stretches. The graph of y equals a times f of x is a vertical stretch or shrink by a factor of a, just like before. If it's greater than 1, it's a stretch. If it's between 0 and 1, a fraction or decimal, it shrinks it. Okay? So, given again, the same one we've been using today. All right, so we're going to vertically stretch by 3. Okay, so that means I'm just going to multiply the whole thing. Again, when we go vertically up and down, we're taking care of the y, so we're doing it to the whole thing. So we're going to go 3 times the whole thing. And we can simplify that by distributing. So that would be our g function when we vertically stretched it by 3. Make it longer so it gets skinnier, right? If we compress it or shrink it, okay, again, those are interchangeable. Compress or shrink, okay? This number is between 0 and 1, some fraction or decimal. Usually they write a fraction, okay? So again, since it's vertical, we're doing it to the whole thing. We're multiplying the whole thing by a half. So I just distribute my half. 1/2 times 3 is 3 halves. And 1/2 times -5 is -5 halves. Okay. So this is linear, not absolute value. So if I look at it on my calculator, let's go back to our 3x minus 5 one. All right, and then 3 halves. So I always put fractions in parentheses with this calculator. There's the original, and there's the other one. It kind of shrunk it towards the x-axis. If it stretched it, it would have taken it up this way more, closer to the y-axis. Okay, if I put the 9x minus 15 in there also, oops. There's the vertical stretch by 3. Original, shrinking it by a half, stretching it by 3. Okay. Steeper. Okay. Lots of stuff I've thrown at you. Okay. So what am I gonna multiply that by? Where's the 2 go? Just inside or times the whole thing? Vertical is the whole thing, right? So you're gonna tell me, Evan? Sure, thanks. All right, so 2 times the whole thing. So that's 2 times the absolute value, oops, minus 10. Okay? We'll make it G again. You can use any letter you want, really. Yes? All right, so there's your assignment. Thanks for paying attention. Again, I know these are long lessons. The beginning is kind of tough. Once we get through this stuff, it'll go a little bit better for us. Keep trying, don't get discouraged. Keep asking questions if you get stuck. That's not right.
Yeah, sure.
This one.
I know.